everyone, thank you so much for coming to this video. So today we're going to be going over how to measure measures of central tendency. So the learning objectives are to be able to calculate and interpret measures of central tendency and variation, and to be able to calculate mean and standard deviation from summary statistics. So I'm going to be going over how to calculate all of these from different types of diagrams, such as histograms or cumulative frequency diagrams. So make sure you review that video on when I was describing what each of these show, as that will come into use for here. But like always, there's going to be timestamps in the description of the video, so feel free to skip to any parts you want to. But let's get started. So there are 5 main measures of central tendency and variation that you need to know how to calculate. So the first one is mean, and to work out the mean, you do the sum of your fx, frequency times x values, over the sum of frequency, sum of f, or the sum of all your x values over n, the number of values you have. Your median is just your middle data value. Your mode is the value that occurs the most frequently. Your variance, there are 3 ways you can measure variance. First one is the sum of your x minus your mean squared over n. So for every value you have, you do that minus that mean squared over the amount of values you have. Or you can do the sum of x squared over n minus your mean squared. So the sum of all your values in your data squared. So the sum of all your data. So you find the square of all your data, sum it all together, and you divide that by the number of values you have, and then you subtract your mean squared from that. Or you can have the sum of your fx squared over your sum of f minus your mean squared. So you'll get the formulas for your variance in your formula booklet, so don't worry about completely memorizing them all. Lastly, you have standard deviation, which is just the square root of your variance. So let's try and apply these formulas to the question. So we want to find the mean and standard deviation of the numbers 2, 3, 4, 4, 6, 11, 12. So first thing first, we want to find the mean. So to do that, we want to find the sum of all our values. So we want to find sum of x. That's just 2 plus 3 plus 4 plus 4 plus 6 plus 11 plus 12. Plug that into calculator, that's equal to 42. Next thing you want to do is you want to do the sum of x over n, which is 42 over the number of values we have. So we have 1, 2, 3, 4, 5, 6, 7. So that's just equal to 6. So that's what 6 is our mean. And now to find standard deviation, we can use either formula. We can either use this one or this one. Let's go with our sum of x squared. So if we do sum of x squared, that would just be equal to 2 squared plus 3 squared plus 4 squared plus 4 squared plus 6 squared plus 11 squared plus 12 squared. And if you apply that in your calculator, you should get that is equal to 346. And now you can do sum of x squared over n minus your mean squared. So that would just be equal to 346 over 7 minus your mean, which is 6 squared. And that's just equal to 13.428. So now your standard deviation, that's just equal to the square root of 13.428. Apply that in your calculator, that's just equal to 3.6623SF. So that's how you can work out mean and standard deviation for a set of values. So for mean, you just add up all your values, divide it by the number of values you have. For your standard deviation, you want to sum up the square of each value you have, divide that by the number of values you have, and then subtract your mean squared from it. So that's to find your variance, and standard deviation is just the square root of your variance. So that's just an overview of how to calculate mean and standard deviation for some values. Let's move on to how to do this for grouped data from a histogram and then from a cumulative frequency diagram. So if you have group data, like we've got over here with the height and number of trees, in order to find the mean, what you need to do is you want to use this formula here of the sum of fx over the sum of f. So to do this, you need to add another column to your table, which is your midpoint, which you can also call your x value. So if we do that, we would get 2.75, 8, 13 and 18. And then the last, and now because we have in a formula the sum of fx, we're going to have another column called fx. So then all we do is we want to multiply our frequency, so 26 times 2.75 to get 71.5. And if we were to do 17 times 8, we'd get 136. Then if we were to do 11 times 13, we get 143. And finally 6 times 18, we'd get 108. So now that we've got our fx, we've also got our f, we can just calculate the mean, would just be your sum of f of x over the sum of f. So we want to sum up all our f of x. So our sum of fx, if we just add up this whole total, that would just be 458.5. And if we were to do the sum of f, so add up this whole column, all your numbers, you'd get 60. So we can just do 458.5 over 60, and that would just be equal to 7.64 meters to 37 SF. So that's how you calculate your mean for group data. So when your intervals are like from 0, have an interval, so from like 0 to 5, rather than just having 2, 3, 4, blah, blah, blah. Yeah, you just want to find your midpoint, which is x, and you'll multiply that by your frequency, and sum up your whole f of x column, sum up your whole f column, frequency column, and just do the sum of f of x over the sum of x. So now if we move on to finding the variance or standard deviation using group data, we need another column here, because if you see this formula here, we have the variance is the sum of fx squared over the sum of x minus your mean squared. So you need another column, which is fx squared. So now all you want to do is you want to do your frequency, 26 times x, your midpoint squared. So you want to do 26 times 2.75 squared, which you'd get is 196.625. Now if we were to do 17 times 8 squared, we'd get 1088. If we were to do 11 times 13 squared, we'd get 1859. Now if we were to do 6 times 18 squared, we'd get 1944. Now if you see the formula, we need the sum of fx squared. So if we add up this whole column, we would get 5087.625. So now we can just work out our variance using all the information we have. The variance is the sum of fx squared over the sum of f minus the mean squared. So that would just be 5087.625 over our sum of f, which we had is 60, minus our mean squared, so minus 7.64 squared. You apply that in your calculator, that's just 26.39. And now for our standard deviation, that's just the square root of 26.39, the square root of our variance, and that's just equal to 5.14 meters to 3 SF. So that's how you find your mean and your variance and standard deviation using group data. So you just want to find your midpoints, find f of x, so do your frequency times your midpoint, and then turn that into your formula for the mean. And then for standard deviation, you want to find your fx squared, use your frequency times your midpoint squared for each values, sum that all up, divide that by the sum of your frequency, and then subtract your mean squared from that. And remember, standard deviation is just your square root of your variance. So the last thing you need to know how to do for grouped frequency is work out linear interpolation. So I've written out the formula here. So your median is the lower common boundary plus the width of class. So that's for the class your median is in, times your position of the median minus the number of frequencies before the class that your median is in over the number of readings in your class. So if we go back to our example here and we want to find your median, the first thing you want to do is you want to find out the class that your median lies in. And to do this, so to find the class the median is in, you would just do n, which is your number of readings, divided by 2. So just do the number of readings we have is 60 divided by 2. So that's just 30. So to find out which class our median, the position 30 is in, we go back to our frequencies and we want to find our cumulative frequencies. So we want to add them all up. So if we start with 26, and then if we do 26 plus 17, we'd get 43. So that means our 30 lies in here in the class 6 to 10. So that's our class our median's in, is in 6 to 10. So now we want to find our lowest common boundary of that class. So LCB of our interval 6 to 10, that would just be 5.5. So you subtract 5.5 from your lowest here, because the one we had before was 5. And then our width of the class, so our upper common boundary, that would just be 10.5. So our width would just be 10.5 minus 5.5, which is just 5. So now we can just fill in our values here. So our median, that would just be equal to the lowest common boundary, 5.5, plus the width, which is plus 5, times the position of our median. So the position of the median, this is 30. Let me just label that there. So times 30 minus the number of frequencies before our class median's in. So the number of frequencies before our class 6 to 10, so we had minus 26, over the number of readings in our class, the number of readings in the class 6 to 10. So we had 17 in that. Our frequency for 6 to 10 is just 17. So now if we were to apply that in our calculator, we should get that is equal to 6.68 meters. And that's in 6.8 meters. And that is our estimated value for the median. So for the median, what you have to do is, first you want to work out your position of the median. So to do that, you want to do your n, which is the number of readings you have, divided by 2. So 60 divided by 2, so we got 30 as our position. And then you want to find out in which class your 30th frequency lies in. So to do that, you want to find your cumulative frequencies. So to do that, you just do 26 and then you'd add 17 to that. And if we did it so on, if we would add 11, we would get 54, then we add 6, we get 60. So then we want to find where our frequency 30, which class that lies in. So we look at that and we know 43 is between 6 to 10 and 26 is between 0 to 5. So 30 has to lie in our 6 to 10 class. Then we just find our lower common boundary of that, which was 5.5. Find out your width, which was 5, then just plug it in to get 5.5 plus 5 times the position of our median, which was 30, minus our number of frequencies before our interval 6 to 10, which is our frequency of the class before, so 26, divided by the number of readings in our interval 6 to 10, our frequency for 6 to 10 was 17. So that's how you work out the median. So that's everything you need to know for grouped data. Now let's move on to working out measures of central tendency and variation for cumulative frequency graphs. So now if we move on to cumulative frequency graphs, and we want to work out our median and our quartiles, So to do this, if we have some values here for height and frequency, and we want to draw a cumulative frequency graph, the first thing you want to do is work out what they would be, so what your cumulative frequencies would be. So you just want to work out your running totals. So you'd get 7, then 7 plus 8, 15, 15 plus 22, you'd get 37, and then 37 plus 3, you'd get 40. So now you can just plot your graph and it would look something like this. So to plot that, what they've done is they have, you start by plotting your lowest value here, that would be 0, and up to 1.4. So you plot 1.4 and your value 7, then you plot 1.6 to the value 8, and so on and so on. So your red numbers is what you plot corresponding to your frequency, to your cumulative frequency, sorry. So for 1.4 we had 7, then for 1.6 we would have 1.6 we have 15, and so on and so on. And then to find our median, what you want to do is you want to work out your median. You want to find your median position. So that will be what your whole frequency is. So it will be 40 divided by 2. So it would be 20. So that's your position of the median. So you would go from 20 and you would go see that where that is on your graph and plot that point. So 20 goes to around 1.6. So that means your median is around 1.65. And then for your lower quartile, you want to work out where the position is. So the position is 40 divided by 4, which is just 10. So you want to see where your 10 is and what your height for 10 is. So that is around, low quartile be around 1.48. And then for your upper quartile, to work out the position, that would just be 40 over 4 times 3. So that would just be 30. So your upper quartile position is just your position that's 3/4 of the way with your frequency. So then you want to see where your 30 is, where that hits the graph, and the height of that. So your upper quartile would be around 1.72. And then your interquartile range is just your 1.72 minus 1.48, which is just 0.24. So that's just how you use a cumulative frequency graph to work out your median, your lower quartile, and your upper quartile. To find the median, you want to find the position. So you divide your frequency by your total frequency by 2 to find your position, and then see where that leads onto your graph. For your lower quartile, your position would be your frequency divided by 4. So here it was 10, and you find the x value that corresponds to 10. Upper quartile is 3/4 of your total frequency, and just find your height or your x value that corresponds to that. And then you can use all your median, your lower quartile and upper quartile to plot your box plot, like what we did in your previous video. So if you've forgotten how to do box plots, make sure you refer back to that video. So that's how you, that's basically all your central tendencies and variations that we need to know. So let's move on how to calculate mean and standard deviation from summary statistics. So summary statistics are just your sum of fx or your sum of fx squared that they may just give you instead of having to work it out, and you just have to work out the mean or standard deviation using them. So for example, let's say we have the sum of fx equals 3550 and the sum of fx squared is equal to 138020, and we want to work out and our n is 120, and we want to estimate the mean and standard deviation of this distribution. So feel free to try it out for yourself if you want to. So to do this, we just plug it in those values into our formula. So we'd have our mean, that would just be equal to the sum of fx over the sum of f. So that would just be equal to 3550 over 120, which is just 29.6. So n20, that's the same as the total sum of your frequency is 20, because you remember if you have cumulative frequency, your running totals will all add up to 120, or the total amount of values that you have. And then your standard deviation, that's just the square root of your sum of fx squared over the sum of f minus the mean squared, which is just 138020 over your sum of f, which is 120 minus 29.6 squared. If you plug that in your calculator, you should get that is equal to 16.58. Which is just 16.6. And that's your standard deviation, your mean. So summary statistics are just these values of your sum of fx or your sum of fx squared that they might give you. So all you have to do is you just need to plug that in to the formulas that you have. So it's variance, standard deviation, they will give you. Mean, you just need to remember that for yourself. So that's everything. So that's everything we wanted to cover. Let's try an exam style question now. So an exam style question here, feel free to pause the video and try it out for yourself first. So we have Adam is measuring the heights in centimetres of his tomato plants. First thing is we want to use linear interpolation to estimate the median height. So to do this, the first thing we want to do is just work out our cumulative frequencies. So that would just be 7 plus 10 is 17, and then 17 plus 15, that's just 32. 32 plus 19, we would get 51 plus 9, so 60. So now we want to work out the position of our median. So that would just be 60 divided by 2, which is 30. So then we want to work out what class this lies in. And then 30 would lie in this class here, 160 to 170. So now we just want to work out our lowest common boundary, which is just 160, plus our width of the class, which is plus 10. Times the position, which is 30, minus the number of frequencies before the class, which was, we have 17 before, over the number of readings in this class, which is just 15. And if we plug that in our calculator, we should get 168.6 recurring, which is just equal to 169. And that's the estimate of our median. The next thing we want to do is we want to estimate our mean height. So to do this, we want to find our midpoint. So we want to find our x's. We have another column like here, which is x. And then, so that would be, or we can do this on this side. So let's say, call our midpoints here, x. So we'd have 145, 155, 165, 175, and then 185. So now we want to do the sum of f of x, and because we know the formula for mean is sum of fx over sum of x. So to do that, we would have 145 times 7 plus 155 times 10 plus 165 times 15 plus 175 times 19 plus 185 times 9. And if you plug that into your calculator, you'd get that is equal to 10075. And then you know your mean is just equal to sum of fx over the sum of f. So that's just 10075 over our sum of frequencies, just 60. And that would get you 167.9, which is just around 168. So that's your answer to your mean. Lastly, we want to work out our standard deviation. So we want to do our f of x squared. So that would just be equal to 145 squared times 7 plus 155 squared times 10 plus 165 squared times 15 plus 175 squared times 19 plus 185 squared times 9. If you apply that in your calculator, you would get that is equal to 1702575. So then we know our variance,
That's just equal to the sum of fx squared over the sum of f minus your mean squared. So that's just 1702575 all over our sum of f, which is 60, minus our mean 168 squared, and then your standard deviation, that's just the square root of that all. So then if you plug this into your calculator, that would just be equal to 113.4 SF, and that's your answer to the standard deviation. Yeah, so it's quite a standard process. For linear interpolation, you just want to use this formula here, so just memorize this. Then to estimate your mean, you wanted to work out your midpoints of your classes, multiply that by your frequencies to get the sum of fx, and you divide that by your sum of frequencies to get your mean. Then for your standard deviation, you want to work out your sum of fx squared, and you just want to plug all your values into the formula for the variance and just square root that to get your standard deviation. So that's everything. I hope you found that useful, and you can now calculate and interpret measures of central tendency and variation, and you can now calculate mean and standard deviation from summary statistics. So make sure you do some practice questions just to make sure you fully understand everything that we've covered.